Hydrogen and its compounds, sulfur and its compounds, and chlorine and its compounds. The series of lessons has been adequately covered to address the content within the syllabus. The content has been enhanced through the use of photographs, animations, illustrations, and videos. To ensure mastery of the content, exercises and quizzes have been included in each of the lessons. It is our hope that you will find this content helpful as you interact with the different topics. Air is a mixture of gases. The behavior of gases is influenced by various conditions, which include pressure, volume, and temperature. The behavior of gases under different conditions are described by gas laws. In this lesson, we will discuss Boyle's law. The following animation shows what happens to particles inside a container when the volume is increased and decreased. Observe what happens carefully. The following graph shows the pressure. In this lesson, the following animation in containers A and B, the number of gaseous particles are the same and in continuous random motion. In container A, the particles occupy a large volume. They collide with each other and hit the wall of the container, therefore exerting pressure. In container B, the volume of the gas in the container is reduced and the particles collide more frequently and therefore increasing the pressure. From the above activity, we can see that when the volume of the gas is increased, the pressure decreases, and if the volume occupied by the gas is reduced, particles collide more frequently and therefore increasing the pressure. Therefore, the volume of the gas is inversely proportional to the pressure applied on the gas. The following graph shows the pressure-volume curve illustrating Boyle's law. Click on the points A, B, and C to observe the illustrations showing the relationship between volume and pressure at these different points. Note that the volume of a gas is inversely proportional to the pressure applied and vice versa. The relationship is expressed in Boyle's law, which states that the volume of a fixed mass of a gas is inversely proportional to its pressure at constant temperature. A plot of the graph of pressure against volume gives a curve as shown below. The graph generally shows that as volume increases, the pressure of the gas decreases. Both pressure and volume never reach zero. Hence, curve does not touch both the x and y axes. If a graph of pressure against 1 over volume is plotted, the graph will be a straight line. Remember that according to Boyle's law, volume of a fixed mass of a gas is inversely proportional to its pressure at a constant temperature. Example 1. A sample of nitrogen gas occupies a volume of 960 cubic centimeters at a pressure of 760 millimeters of mercury. Calculate the pressure of a gas if it's compressed to a volume of 100 cubic centimeters. Step 1. Remember, pressure 1 multiplied by volume 1 is equal to pressure 2 multiplied by volume 2. From the question, pressure 1 is equal to 760 millimeters of mercury. Volume 1 is equal to 960 cubic centimeters. To calculate the unknown final pressure 2, substitute the value for pressure 1 multiplied by volume 1 is equal to pressure 2 multiplied by volume 2. 760 millimeters of mercury multiplied by 960 cubic centimeters is equal to example 1. Pressure 2, a sample multiplied. Make pressure 2 the subject of the formula. Therefore, pressure 2 is equal to pressure 1 multiplied by volume 1 divided by volume 2. Pressure 2 is equal to 760 millimeters of mercury multiplied by 960 cubic centimeters divided by 100 cubic centimeters. Pressure 2 is equal to 7,296 millimeters of mercury. In this lesson, we will discuss the Charles law. Observe the following animation and note the increase in gas volume when heated at X. Particles moving randomly in the container. Gradual increase in gas particles movement and piston moving up to point B. The movement of the piston when the Bunsen burner is put off. Note also what happens when the piston moves down to point A. Consider the results obtained from the experiment where the volume of helium gas was measured against temperature at a constant pressure of 1 atmosphere. To draw a graph of volume against temperature, follow steps below. The result of the experiment shows that if the gas is cooled to negative 273 degrees Celsius, the volume would be zero. Practically, real gases cannot cool to negative 273 degrees Celsius because it liquefies before that temperature is achieved. This temperature of negative 273 degrees Celsius is referred to as absolute zero temperature, the 0 point on Kelvin, that is absolute temperature scale. To convert to degrees Celsius to Kelvin, add 273. For example, 25 degrees Celsius is equal to 273 plus 25 degrees Celsius, which is equal to 298 Kelvin. Click on the Enter button to follow up on a worked example. In this lesson, we will discuss combined gas law. Remember, Charles' law states that volume divided by temperature is equal to constant. Boyle's law states that pressure multiplied by volume is equal to constant. By combining the two laws, we obtain the combined gas law given as pressure multiplied by volume divided by temperature is equal to constant. When comparing the same quantity of a gas under different condition, we obtain pressure 1 multiplied by volume 1 divided by temperature 1 is equal to pressure 2 multiplied by volume 2 divided by temperature 2, which is equal to constant, where P1 is initial pressure, T1 is initial temperature, V1 is initial volume, P2 is final pressure, T2 is final temperature and V2 is final volume. In this lesson, we will discuss Graham's law of diffusion. To investigate what happens to a crystal of potassium manganate 7 in water, click to play the video and observe what happens.
Investigate what happens to a crystal of potassium manganate 7 in water. These are what you are going to use. A beaker, 250 millimeters, a straw or a glass tube, a washing bottle containing distilled water, potassium manganate 7 crystals, and a spatula. Here is the procedure. Put 100 milliliters of water into a 250 milliliters beaker. Place a glass tube or a straw in the middle of the beaker. Put a small crystal of potassium permanganate 7 into the middle of the beaker through the glass tube. Close the straw using your first finger to avoid disturbing potassium manganate 7 crystal. Slowly remove the straw and allow it to stand for about 30 minutes.
When potassium manganate 7 is put in water, the water slowly turns purple. The particles of potassium manganate 7 spread from the bottom of the water in the beaker towards the surface. To investigate what happens when drops of bromine liquid are in a gas jar.
The following experiment is performed in open air or a fume chamber because bromine liquid is very poisonous. The reagents and apparatus to be used in this experiment are 2 gas jars, a teat pipette,
When bromine liquid is placed in a gas jar and another gas jar is inverted over it, brown fumes of bromine vapor spread from the inverted gas jar after a short time. Conclusion: from the two experiments, particles of gases and liquids spread from areas of high concentration to areas of low concentration through the process called diffusion. To investigate the rate of diffusion of different gases, click to play the video and observe what happens.
The apparatus and reagents to be used in this experiment are a long glass tube, a 100 milliliter beaker, concentrated ammonia solution, concentrated hydrochloric acid, a pair of forceps, and cotton wool. Clamp a long glass tube horizontally. At the same time, plug one end of the long glass tube with cotton wool soaked in concentrated ammonia solution, and the other end with another cotton wool soaked in concentrated hydrochloric acid.
Hydrogen chloride and ammonia gas diffuse from the opposite ends of the long glass tube. When they meet, they react to form a white ring of ammonium chloride. Conclusion: ammonia with the RMM of 17 is lighter and spread to a longer distance than hydrogen chloride with RMM of 36.5. The white ring of ammonium chloride is formed nearer to the hydrogen chloride at the end of glass tube. Therefore, the heavier the gas, the slower the rate of diffusion, and the lighter the gas, the faster the rate of diffusion. The behavior of gases when they diffuse is summarized by Graham's law, which states that at a constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its density. Remember Graham's law, which states that at a constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its density. Two gases of A and B have densities of 0.18 grams per cubic centimeters and 2.9 grams per cubic centimeters respectively. If they diffuse under the same conditions, What are the relative rates of diffusion? (100 cubic centimeters of gas X diffuse from a porous plug in 10 seconds, while 300 cubic centimeters of hydrogen gas diffuse from the same apparatus in 5 seconds. Under the same condition of temperature and pressure, calculate the relative molecular mass of X. H equals to 1.